Hi all, so this is the last hypothesis testing this week, in which it's paired t-test, which is also sometimes called the dependent sample t-test. It's different than the last t-test we did. The last one was two sample t-test, or also known as independent samples t-test. Just like we did before, you don't have to worry about z versus t. We will just use t in this case. So for the first thing we need to do is talk about what does it mean to be a paired t-test. How is it different than the independent samples? Well, what we're looking for is whether the data is paired in some way. For paired data, also dependent data, the observations are paired in some way. That's obvious. A lot of times it comes from before and after measures, repeated measures on the same item or person, or any other way that we can match two pairs together. For independent samples, the observations are not paired in any way. You don't even have to have the same number of observations in the two samples, like our examples in the previous slides. We didn't have to have the same number of observations. Paired data really comes down to one sample with multiple measures compared to independent samples, which are really two different samples. So take a look at these four examples and see if you can figure out if they're paired or independent samples. Pause the video and write down your answers. Then we'll go over them to see how many you can get right. So the first one, on average, do husbands earn more money than their wives? In this example, we have husbands compared to their wives. So we would have those husband-wife pairs. Since you don't want to compare one husband to someone else's wife, these pairs cannot be separated. So it's paired data. And then the next one, at Banks of America, do men earn more money on average than women? And that's independent because really we have two different samples of men and women. So the difference of the first two examples is that the second one, we're not comparing specific pairs to each other. So we don't have that wife and husband pair. We have two separate samples. Okay, so for the third example, do houses with garages sell for more on average than houses that do not have garages? Well, those are two different samples. We don't have any pairing going on, so this is an independent sample. Okay, for the fourth one, does a typing tutorial increase students' typing speeds on average? And this, you can just see it's a before and after scenario. So this is a paired data. So here's another example with shopping lists to different stores, and we're comparing the cost. And we want to know whether store one is more expensive on average than store two. Well, the way we conduct this test is that we compare the difference. So we compute the difference by saying store one minus store two. For instance, here 1.89 minus 1.99 means that gives us a negative 0.1, which is 10 cents. So store two was 10 cents more expensive than store one, and we do that for all of these then. And it doesn't matter which way you do the subtraction, so you could do store two minus store one instead, as long as you are consistent throughout the problem. And then notice here that if the price of store one is bigger than the price of store two, the difference will be greater than zero. So for instance, item B, store one is greater than store two, so the difference is greater than zero. Otherwise, we'll get a negative difference if store two is bigger than store one, and we saw that in item A. And if they're the same, our difference will be zero. And this matters because what we want to do now is look at the mean difference. And what we do for a paired test is really just a one sample t-test for those differences. So the mean of the differences, we call that x bar with subscript d, so x bar d. So looking back at the previous table, if we take the mean of these numbers, that's the differences these numbers are, that's x bar with the subscript d, so x bar d. And we use that as a point estimate for mu d, the population mean of the difference. Remember, x bar is always the point estimate for mu. So we did our calculations as store 1 minus store 2. If we do a hypothesis test and we can conduct that the population mean of the differences, mu d, is greater than 0, then we know that store 1 is more expensive on average. So we always want to compare to 0. So the hypothesis value for a paired test is always 0. So just remember that. So for our example, our hypotheses are right here. We wanted to know if we could conclude if store 1 was more expensive than store 2. So the null hypothesis is that there is no difference in the prices on average, which means that mu d equals 0, and then versus store 1 being more expensive on average, which we said is mu d is greater than 0, since we did store 1 minus store 2. If we did the other way, store 2 minus store 1, our alternative would be just switch, so it would be mu d less than 0. So just make sure you're consistent on your signs, and that comes from how you did your subtraction. So from StatCrunch, we get the test statistic, just like we did for the other test. We get the test statistic and the p-value. Our test statistic is 1.5046 and our p-value is 0.0854. And as always, we state our rejection rule, and we reject H0 if p-value is less than 0.05, that's our alpha level. And our p-value is greater than 0.05, so we fail to reject H0. There is insufficient evidence to conclude that store 1 is more expensive on average. And remember, we are inferring to the population. We know what the sample looks like, so what we want to know is about the population. And this is always going to be true. So here's what the output looks like from StatCrunch, and it provides the sample difference right here. And that's store 1 minus store 2. That means that store 1 has and store 2 have a difference of about 19 cents. So according to our sample, store 1 was about 19 cents more expensive than store 2. And the notation in StatCrunch, I want to note, is mu1 minus mu2. This is not the standard notation. Mu d is the standard notation, and that's what your textbook uses, mu d. And StatCrunch it's not incorrect to use mu1 minus mu2 technically, but the calculation for the test statistic uses the standard deviation of the differences, which is not the same to just subtract the standard deviation for each set of pairs. So it's not like if you took the standard deviation of, if you found the standard deviation of store 1 and store 2, you couldn't just subtract them. So I like to keep it simple, and I'm always using mu d, but if you use it either way on your homework, you won't get points off if you use it correctly. So here's another example. We have a car company with a new gasoline additive, and they claim that it improves gas mileage. So we are taking 10 cars and we measure gas mileage with additive and without the additive. So we have repeated measures. For instance, the first car here had 28 miles per gallon without additives and 31 miles per gallon with the additive. So that's why this would be a paired t-test. We have 10 different cars, 10 different cars that have repeated measures. So it's a paired t-test. So we can pick which way we want to do the subtraction again. What I usually do is try to have the difference be the biggest minus the smallest according to the hypothesis. That way the alternative is always greater than 0. That's just how I do it to keep it simple so I remember the alternative. But you don't have to do it this way as long as you are consistent. So according to this example, the additive is hypothesized to be higher. So our difference will be calculated as with minus without. And here's the output from StatCrunch. The sample difference is 1.6, which means on average, when the car had additive, it gets 1.6 more per gallon than without. And here's our test statistic and our p-value. With this p-value, it's 0.0147, and we have to state a rejection rule, like always. Reject H0 if p-value is less than 0.05, that's our alpha level. So our p-value is less than 0.05, therefore we reject H0, and there's sufficient evidence that gas mileage is higher with the additive. So that's it. Just make sure you watch the tutorial videos to know how to do this in StatCrunch.